To the final of these energy system tutorial lessons. I'll try and make this one as short and sweet as I possibly can. We're talking about the third energy system today. Remember, these are not sequential. It's only sequential like this if we talk about the dominance of the energy system and if we're talking about somebody who is performing exercise at a maximum intensity. So for us right now, we've got the athlete, they've been on that bike, they've used up their 3 seconds of stored ATP, they've gone through the next couple of seconds by breaking apart some phosphate creatines and putting ATP back together, and then we ran out of phosphate creatine, so we had to start breaking down the glucose or the glycogen, turn it into glucose, go through that glycolysis process, and as I said, once we've left with pyruvic acid, the body asks that question, do I have enough oxygen? So the reason why at this current point that the athlete in the anaerobic system is fatiguing is because the pyruvic acid has no oxygen to bond to, and it becomes lactate and hydrogen ions, and that's that acid that puts the pH out of balance and makes the muscle stop contracting. However, after we've run for a certain period of time, the heart rate and the breathing depth and rate, respiratory rate, tidal volume, once all of those things have got to their point that are supplying the muscles with enough oxygen, the aerobic system will become the dominant energy system in the body. Here's a few little notes that I'd like for you to write down, or you can put them into your own words as you go through. So the aerobic energy system, not just the aerobic glycolysis system, because the aerobic energy system is the system that you can see me using dominantly right now. It's perfect. It's the preferred energy system when I'm at rest or submaximal intensity exercise, when I just go for a walk with my family, when I'm sitting down running a Zoom lesson. My body is burning free fatty acids that I've eaten from the triglycerides and the fats, from the oils, the nuts, the animal fats on the side of that lamb or steak. When I ate those foods and they turned into free fatty acids, they provide me with the fuel to be able to record this video at 7 o'clock at night. When I'm exercising though, the body would prefer to use carbohydrates, which are stored as glycogen, transported and used as glucose. The reason being, the body can break down carbohydrates much quicker and easier than it can break down fats. And we want energy to still be coming relatively fast into the body. So this is the only energy system that utilizes oxygen. The ATP-PC and the anaerobic systems don't refer to oxygen in their equations. This one does. Roughly after an athlete is sprinting maximally for 75 seconds, the majority of their heart rate, breathing rate, and all of those contributing factors to get enough oxygen will be near their maximal intensities and starting to actually make this the preferred energy system, okay? So when the aerobic system becomes the preferred energy system, we are able to not fatigue as much. The problem with this energy system though is that with more chemical reactions, it gives us the ATP resynthesis at a slower rate. So while the phosphate creatine was instantaneous and put ATP back together, while the glycolysis process is fairly quick and gives us a little bit of energy, the aerobic system takes a little bit longer because there's more steps to the equation. The good part of this energy system though, as I said before, there are no fatiguing byproducts. There's no lactic acid. This energy system can run for hours. I ran a 23-kilometer run on Sunday this past week, and if I wasn't able to run for 2 hours without stopping, this is proof that this energy system can provide us with energy for hours. I consume no food, no anything, no snakes, no gels, no nothing during that run, just from the stored carbohydrates and potentially fats that were eaten through my diet. My body was able to get my heart rate and breathing rate to a specific point and run for hours. What I'm going to do is I'm actually going to draw the equation for you right now. like you to realise that the equation's quite simple to understand if you remember the anaerobic glycolysis equation. So we started with either glycogen, which is the stored form, or glucose, which is the transportable form. And we actually take that glucose through the glycolysis process, and that glycolysis gives us energy, and that energy puts ATP back together. It finds the ADP and P, it puts that bond back together by replacing the energy and making that third bond stable again, and then allowing us to move a muscle using ATP. And remember how that glucose, after the glycolysis process, has to become that pyruvate. Pyruvic acid is not a good nor a bad thing. I've said all this in my previous video. Go back and watch it if you need to. That's why they're there on YouTube. But as I said, the question was, is there enough oxygen present in the body at the muscle at that time? The answer now is yes. So the oxygen bonds with pyruvic acid in this situation. And when pyruvic acid has oxygen to bond with, four things occur. The first thing that occurs is that we produce CO2. CO2 is carbon dioxide. Carbon dioxide is not a bad thing. When we breathe oxygen in, we breathe out carbon dioxide. And this is the reason why. Because the body goes through the aerobic system and produces carbon dioxide when oxygen and pyruvic acid bond together. The next thing that you'll notice that the body produces when oxygen and pyruvic acid get together is heat. When the body produces heat, the body actually speeds up some processes. When things are warmed up, they actually perform their chemical reactions faster. So while heat could potentially mean a bad thing because we overheat in a really sunny, hot situation, inside the body, especially on a cold morning, once you've had a warm up, your body starts to produce heat. All of these chemical reactions happen quicker. The next thing that's produced is H2O, which is water. And we know that as we start to sweat from year 11 PE, because the body is heating up, we're losing blood volume through the H2O, the water that was in our blood volume. And so H2O is being produced with oxygen and pyruvic acid together, and it's replenishing that inside our body. The final thing that's actually produced is more energy, which, you guessed it, puts more ATP back together. What I would like you to do is, from the notes that I gave you on this side and the diagram that I've given you on this side, have a go at writing some very basic notes and also drawing that diagram into your book before you join today's Zoom call.